So today we've been asked to sketch the following: r equals 4 cosine 3 theta. And I've gone ahead and taken the liberty, whenever you have something you don't know the shape of, you have to figure out what your independent and your dependent variable are. And in this case, our independent variable is theta, and our dependent variable is r. And so what I've done is choose some values for theta: 0 degrees, 15 degrees, 30 degrees, 45 degrees, 60 degrees, on and on and on. And you plug this value into theta. So for an example, 0. Okay? 3 times 0 is 0. Cosine of 0 is 1. 1 times 4 equals 4. R equals 4. Okay? And so I've taken the liberty of making a table here. From 0, theta equals 0, all the way down to theta equals 180. And then plug each of these values of theta into this equation and find r. Okay? So I've got 4, 2.8, 0, negative 2.8, negative 4, negative 2.8, 0, etc., etc., etc. And we want to sketch this. Now, whenever you see r and theta as your independent and dependent variables, you are in polar coordinates. You're talking about polar coordinates. And to graph a polar equation, you have to have polar graph paper. So I'll zoom out just a speck here. And polar graph paper has angle marks: 0, 30, 60, all the way around 360 degrees. And then it has concentric circles. So 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7. So this goes out 8 units and is in increments of, I believe, 7.5 degrees, somewhere like that. So, you start at 0, this is 30, so halfway between 0 and 30 would be 15, and then, of course, half of that. So you have pretty small increments here. Now, what I have to eventually do is plot these points here on this graph paper. Okay, so take a look at those points for a second: 0, 4, 15, 2.8, 30, 0, 45, negative 2.8, 60, negative 4, 75, negative 2.8, 90, 0, 105, 2.8, 120, 4, 135, 2.8, 150, 0, 165, negative 2.8, and 180, negative 4. I'm going to plot each of those points on this polar graph paper. Okay? And basically we start at 0 degrees. Okay? And at 0 degrees, r is 4. So you're always going to start on your positive x-axis. Okay? And that's going to be a positive r. A negative r would be in the opposite direction. Okay? So I'm going to go out to 1, 2, 3, 4. And I'm going to make a point. The next point I had was 15 degrees, and 2.8 was r. So here's 15 degrees. Okay? And I'm going to go to 2.8. So on that line, I have to go out 1, 2, and 2.8 is going to be just shy of 3. So we're going to make a point somewhere like that. Okay? And the big thing about this is you have to keep track of your points. So I'm going to number them: 1, 2. Because you have to connect the dots in the order that you make the points. 30 degrees, the radius is 0. So that's going to be at the origin, point 3. 45 degrees was negative 2.8. Now, this is 45 degrees. A positive r would go this way. So a negative r will go this way. So a negative r will go this way. Okay? And so it says negative 2.8. So I go negative 1, negative 2, and negative 2.8 will be somewhere about there. And that's point number 4. Point number 5 is 60 degrees. So there's my 60 degree line. And negative 4. So instead of going 4 in this direction, we're going to go 4 in this direction. So 1, 2, 3, 4. And that's point number 5. And I'm just keep making tiny little marks to keep up with the order these are connected in, okay? Point number 6 will be 75 degrees. So here's 75 degrees. And 75 degrees, and the radius for 75 degrees is negative 2.8. So 2.8, if the radius was 2.8, I would go this way. But since it's negative 2.8, I go this way. So I go along this line right here, 1, 2, and again it's 2.8, so we're going to go somewhere close to 3. And that's point number 6. Okay, so that's point number 5. That's point number 6. I'll connect these in the order I make them. The next one is 90 degrees, and the radius is 0. So that's going to be the origin again. So that's going to be point 3 and point 7. The next one is 105 degrees. So that'll be right here, 105. And the radius at 105 is 2.8. So I'm going to go out 1, 2, 0.8, and that's point number 8. The next point is 120 degrees and a radius of 4, so 1, 2, 3, 4, and that's point number 9. The next point is 135 degrees, okay, and that's going to be 2.8, so we go out 1, 2.8, and that's point number 10. The next point is 150 degrees and a radius of 0. 150 degrees and a radius of 0, which is going to be the origin again, and that's point number 11. The next point will be 165 degrees and a radius of negative 2.8. So positive 2.8 would be going towards 165. Negative 2.8 will be going away from it. So we're going to go this way right here. And we're going to go 1, 2.8. And I know I'm finished because my last point, this is point 12, my last point is 180 degrees and a radius of negative 4. So a radius of positive 4 would be going towards the angle. A radius of negative 4 goes away from it, which would be, oh look, the same point I started with. And this is point number 13. And so when you get back to the point you started with, usually what that means is you can stop. Otherwise, I'd have to go all the way around to 360 degrees. Okay, so I start at point 1 and try to very smoothly connect the dots. So point 2, point 3, point 4, point 5, point 6, point 7, point 8, point 9, point 10, point 11, point 12, and point 13. And I get, ta-da, what we call in trigonometry a rose curve. And if you look at the original equation, which I'm just going to throw up here for a second, this determines the number of petals, and this determines the length of the petals. The length of the petals is 4, and the number of petals is 3. And this number depends on whether it's odd or even. But in the case of an odd number, that is the number of petals. So we have 3 petals, and each petal is 1, 2, 3, 4 units long. 1, 2, 3, 4 units long. 1, 2, 3, 4 units long. Okay, so that's how we graph this by hand. Now, I'm a big fan of technology, and we have lots of technology in the classroom and in industry today. And so I have a TI-84 here, and you can use an 83 or an 85 or an HP, any competitor. And the first thing we would need to do here is, I'm going to zoom in just a little bit, is the standard, the default mode for these calculators is right here, FUNC, function notation. Well, this is not a function. It is a polar equation. So we need to scroll down here and go over to polar. Okay, change our mode to polar, hit enter. Notice it now highlights polar. And we can get out of this menu. There's a button here in blue. It says quit. So it's in blue, so you have to second and quit, and that'll get you out of that menu. Okay. Now when I press the Y equals key, notice instead of Y1, Y2, Y3, we get R1, R2, R3. And this is specifically set up to enter an equation that looks like this. Okay, so what we're going to do is type that equation into my TI-84. And we're going to say 4 times cosine. Now, you notice when you press the cosine key, it throws up a parentheses. So I'm going to insert that here. We have to remember to close that here. Now, 3, real quick point, if you use these calculators, there is a button. I'm going to zoom into that button there. It says X, T, theta, and N. This is your variable key. Anytime you are graphing an equation, this needs to be the variable that you input into your calculator. Okay? And what you'll find out is your calculator is very smart, and when you press that button, it throws up the theta symbol because it knows you're in polar coordinates. And we'll close that parentheses. The next thing I want to show you before you press the graph button is press the window button. And if you've used these before, you'll notice a familiar difference. Normally you have X min and X max and Y min and Y max and all these fun things. But you'll notice a difference here at the top. You have theta min, theta max, and theta step. Now, I've got my theta step set to 10 degrees, and I'm going to go from 0 to 180. And I press graph. And voila, what do we see? We see a flower with 3 petals, and one of the petals happens to land on the x-axis. What did we have? A flower with 3 petals, and one of the petals happened to land on, ta-da, the x-axis. Okay? So a very similar picture here. Now, obviously a little smaller than my hand-drawn version. What if you get a picture that looks like this? That looks funny. Or let's say this. Looks kind of, I'm going to zoom in just a little bit here. Zoom in. I'm going to zoom in. A little too much. Okay. A little too much. How about that? That's kind of ugly, isn't it? That doesn't look very smooth. The trick is that the bigger you make theta step, the less points your calculator has to connect. So I always recommend, if you're in degree mode, making theta step, say 5 degrees. If you're in radian mode, I suggest making theta step something like pi over 8, pi over 12, a small value. And then when you do that, you get a very smooth curve. Okay? So that's how you would graph this using your graphing calculators. Put it into polar mode, and then make sure that when you're setting up your graph that you tell it to choose a lot of points. Another quick note here, you know, I had all these values done. Ta-da! One thing you can do is you can use the table on your calculator to find these values. Okay, so if you look here in blue, you see the word table, and if I go to table, I see, right, theta equals 0, theta equals 15, 30, 45, 60, and you see all these values. So it's a very quick, easy way, if you had to graph this by hand, to fill that table out, because your calculator is plugging in these theta values and finding the R values for you. So a real quick lesson on polar coordinates and graphing and technology. Polar coordinates are an integral part of both trigonometry and calculus, and they're used quite extensively in some fields. So if you have any questions about this or anything you want to discuss as far as this is concerned, let me know, and hopefully this has helped you.